Hello, chemistry students. Today's lecture is from Chapter 11. It's lecture number 2. This chapter is really short, so we only have 2 lectures. In your book, the first problems we're going to work are on page 373. So you'll need your book. You will need your lecture notes. We're on page 3 down near the bottom. We're going to finish those up. And you'll need a periodic table to add up molecular weights. Okay, first thing we're going to talk about today is called freezing point depression. So when a solute dissolves in water, the solution always has a lower freezing point than the pure solvent. So the example here would be you treat roads with salt before it snows, and that causes the freezing point to go from 32 degrees down to lower, let's say 24 or 25 degrees. So the snow will melt until it gets down below a temperature of 24 or 25 degrees, depending on what kind of solution they put on the road. So why does this happen? The mutual attraction between the solute and the solvent adds energy to the solution. Therefore, the temperature must be lowered to get the solution to freeze. So in this space down at the bottom of your notes on page 3, I want you to write all this in. So we have a equation. The change in temperature is equal to minus I times K sub F times molality. Delta T, you might remember delta T from the calorimeter chapter. That just means change in temperature. K sub F is a freezing point depression constant. It's different for each substance. Okay, so whether it's water or alcohol or whatever, each substance will have a different freezing point depression constant. I is the number of ions or molecules that the solute splits into. If it's a molecule, I will always be 1. Okay, if it's an ionic compound, then it will be the number of ions in the compound. M, as we learned in the last lecture, means molality, so we'll have to calculate that. And remember, water freezes at 0 degrees Celsius. So any other substance that is the solvent that we're talking about, you will be given the freezing point, but you do need to remember that water freezes at 0 degrees C. All right, we'll leave the equation up there. Let's look at page 373. So that 11.7 says, in order to prevent the water in a car's cooling system from freezing, people add antifreeze to the water in the radiator. The antifreeze is typically ethylene glycol, that's C2H6O2. What's the freezing point of a radiator solution made from 4 kilograms of water and 1 kilogram of ethylene glycol? And for ethylene glycol, K sub F is 1.86 degrees Celsius per molality. All right. So first of all, we know if this is C2H6O2, that is a molecule, not an ionic compound. So for a molecule, I is always equal to 1. When you dissolve it in water, it splits into its individual molecules, not its ions. K sub F is in the problem. That's 1.86 degrees C per mole. All right, we need to figure out the molality. All right, so first of all, we need to figure out the moles. So it says we have 1 kilogram, that's 1,000 grams of C2H6O2. Got to change that to moles. If you add up C2H6O2, 12 times 2 on the carbons, plus 1 times 6 on the hydrogens, plus 2 times 16 on the oxygen, you'll get 62 grams. So 1,000 divided by 62 would be 16.11 moles. So our molality is equal to moles of solute, 16.11, divided by kilograms of solvent, which is water, so 4 kilograms. Now you have to be careful. Don't divide it by the 1 kilogram because that was of the solute. All right, solute over solvent. So that is a molality of 4.03. Now we can get how much does the temperature drop? What's the change in temperature? So it's minus I times K sub F times N. Well, I is 1. K sub F is 1.86. And then our molality is 4.03. Okay, put it right there. So that is negative 18, excuse me, sorry about that. That is negative 7.49 degrees Celsius. So since it's water, we would subtract 7.49 degrees C from water since it starts at 0. So this is just the answer. That is the new freezing point, negative 7.49. If this were a different substance, if we were dissolving it, for example, in alcohol or something like that, we would subtract from the freezing point of that substance. But since this is water, we can just say it's negative 7.49 degrees C. All right, pause if you need to, and I will do 11.8. So 11.8 says, if a solution is made by dissolving 2.3 grams of magnesium hydroxide into 25 grams of acetic acid, what is the freezing point? K sub F of acetic acid is 3.9. Okay. The freezing point of pure acetic acid is 16.6 degrees. So we're going to be subtracting from 16.6, not from 0. All right, first of all, let's figure out the solute is magnesium hydroxide. So how many ions does magnesium hydroxide split into? Well, it splits into, you only have one magnesium and you have two hydroxides. So for I, it's just going to be one magnesium plus two hydroxides, so that's going to be 3. All right, we also know K sub F for this substance, it says in the problem, is, let's see, 3.9. So we need to figure out the molality. All right, so to do that, we got to figure out moles, 2.3 grams of magnesium hydroxide. Let's get that to moles. Adding up magnesium hydroxide, that's 58.3. Remember, you got one magnesium, 2 oxygens, and 2 hydrogens. So that add up to 58.3. So that is 0.0394 moles. So now we can get the molality. That's moles per kilogram. So that's 0.0394. And reading the problem, how many kilograms do we have? Well, it says we have 25 grams. So 25 grams, if you move that decimal point 3 places to the left, is 0.025 kilograms. So that is a molality of 1.58. So now we can get the reduction or change in temperature. It's minus I, we said I was 3, times K sub F, 3.9, times the molality, 1.58. So that's just the concentration of the solution. All right, put that in your calculator, get negative 18.5 degrees C, but that's not the answer. The new freezing point, you're going to take the original freezing point, 16.6, because this is acetic acid, not water, and then subtract 18.5. So that is negative 1.9 degrees C. All right, there's a couple of freezing point depression problems for you. Freezing point is reduced. Now let's work a couple of boiling point elevation problems. All right, pause if you need to. All right, if you'll look at the middle part of page 4, the last page of your notes, we talk about boiling point elevation. When a solute is dissolved in a solvent, the boiling point of the resulting solution is higher. So with freezing point, it's lower. With boiling point, it's higher than the pure solvent. And why is that? Since the molecules of the solute and solvent are attracted to each other, they're harder to pull apart and need more energy to make the solution boil. So the boiling point elevation equation, write this in. You'll have to memorize this. And that is delta T is equal to I times K sub B times N. So instead of K sub F, which was the freezing point depression constant, you have K sub B, the boiling point elevation constant. All right, let's work a couple of these. Look at 11.9. All right, 11.9. It's one page over, so page 375 says acetic acid has a K sub B of 2.93, a normal boiling point of 118.1 degrees C. Need to remember that. What would be the boiling point of a solution made by dissolving 50 grams of calcium carbonate in 500 grams of acetic acid? All right, so first of all, let's get I. All right, so we are talking about calcium carbonate. All right, so CaCO3, it would split into one calcium ion and one carbonate ion. So just one of each. So I is equal to 1 plus 1, which is 2. All right, K sub B is in the problem. That is 2.93. We need to get molality. Okay, so we're given 50 grams of calcium carbonate. Let's change that to moles. Add up calcium carbonate. So for calcium, you'd have 40.1, I believe. Carbon 12, oxygen 3 times 16 would be 48. All right, so that's going to add up to 100.1 grams. All right, so put that in the calculator, you get a nice 0.5 moles of CaCO3. You might not even have to put that in your calculator. 50 divided by 100, 0.5. Okay, so you've got that. That's not the molality though, is it? It's 0.5 moles divided by kilograms of solvent. All right, so our solvent is 0.5 kilograms. Now if you look at the problem again, it said 500 grams. Okay, 500 grams. You got to change that to kilograms by moving that decimal place 3 places to the left. Right, so that's a molality. Probably don't need your calculator of 1. So boiling point elevation is I. All right, here's our formula. I is 2. K sub B is 2.93. And molality is just 1. So that's 5.86 degrees C. Our new boiling point, we have to add that to the original boiling point. Our original boiling point was 118.1 because it's not water, plus 5.86. So that is 123.96. All right, hope you think this isn't too bad. Let's work one more and we'll be done with chapter 11. So pause if you need some time to finish this up. All right, 11.10 says if you wanted to boil a solution made by dissolving 250 grams of table sugar, all right, that's a molecule, not an ion, 250 grams of table sugar into 1.3 kilograms of water, to what temperature would you have to raise it? All right, and in case of B of water is 0.512. So we're back to a solvent of water. All right, so our table sugar is C12H22O11. That is not an ion. That is a molecule. When I was teaching you just a few minutes ago about freezing point depression, we said for a molecule, I is always equal to 1. We know that K sub B for water, that's in the problem. You'll always be given that, and that is 0.512. We need to get molality. So first let's get moles. So we have 250 grams, C12H22O11. Adding up this table sugar would be 12 times 12, which is 144, plus 1 times 22. So add 22 to that, plus 16 times 11, and that'll give you 342 grams. So 250 divided by 342 is 0.731 moles. That's not molality. Molality is moles per kilogram. All right. We have 1.3 kilograms. So I don't think we even had to convert there. So that is 0.562. Sometimes people forget to do this step and just put 0.731, put moles instead of molality. Don't do that. So delta T is equal to I, which is 1, K sub B, which is 0.512, and then molality 0.562. All right, and that is 0.29 degrees C. So our new boiling point, we have to, it's not 0.29 degrees C. You know the boiling point of water is not that cold. That's almost the freezing point of water. You add this to what? 100. So that's 100.29. So it didn't raise it much, did it? Sugar's not a very powerful boiling point elevator. All right. So let me just hold on just a second, and I will give you the homework assignment that goes with this. All right, so your homework is going to be, let's see where we left off last time. Number 10. So we've got review questions on page 381. You can do number 10 and practice problems, page 382. You can do 8 through 10. All right, so let's see. We did through number 7 last time. I'm just going to make sure on this. Yep, that is right. 8 through 10. So there you go. I hope you enjoyed chapter 11, and I will talk to you next video.